Hello guys and welcome back to my channel. Today we are going to do grade 11 question paper physics. We are only going to do question 2 because it consists of vectors. I still want to do grade 12, 11 and 10 questions, and then from there I'm going to do topics or chapters whereby I'll be explaining them in details before doing question papers or questions. I'm only doing this because I think I'm 2 weeks behind. I've been trying to figure other things out. So yeah, let's get to it. So as you can see there, it's question number 2 on your physical science question paper grade 11. So what does it say? It says two forces of magnitude 50 Newton and 80 Newton act at a point on a Cartesian plane in the directions shown in the sketch below. So we have two vectors. The other one acts to that direction, which we can say it's northwest, sorry, and then the other one acts to this direction, which is east. You know guys, like we have north, south, west and east. So this one act this direction, so it's northwest. This one act directly to east, so it's 80 Newton with no angle, and then this one is 50 Newtons with 30 degrees angle. So let's look at the first question. So it's 2.1. What does it say? It says give the correct term for the following description: a single vector having the same effect as two or more vectors together. So we have two vectors here, one go in that direction, one go in that direction. So if we have to replace them by one single vector, so we're gonna draw it like this guys again. So that's if we have to replace these two vectors, but then we still have to calculate the components first of the vectors. So that term we call it a resultant vector or force. So that's the term that they want there guys. So we have 2.2. It says calculate the magnitude of the vertical component of 50 Newton. So which force do they want here? They want the magnitude of this component here, the y. So we have 30 degrees here, and then we have x here if we complete this triangle, but then we are only looking for this one. So we are going to use our maths guys. So which trigonometric ratio can we use? We are going to use sine theta is equals to opposite, which we can represent it by y, over hypotenuse, which is r, 50 Newton. Why are we using that? Because at least we have two values that we know. We have our theta, we have our r. So our theta is going to be sine 30 degrees is equals to y, that's what we are looking for, and then 50 we have. So we can multiply this side, 50 sine 30 degrees, which is equals to y. That's what we are looking for if you are going to punch it on your calculator, because sine 30 degrees is half, so half of 50 is 25 Newton. You can also punch it on your calculator guys. It's 50 sine 30, so it's 25 Newton. And then check your directions guys. This vector goes up, but then it goes to the left. So up we can consider it as positive, and down we can consider it as negative, and then to the right as positive, to the left as negative. So you will see why that is important. So let's go to 2.2.2. so it says the magnitude of the resultant net force. So we have these two vectors, remember, the 80 Newton and the 50 Newton. So we should first get the components of this and the components of this and add them together and get the resultant. So the components of the, we can start with the, you can say for 50 Newton force, what do we have? The first vector is y, this one guys, we got it as 25 Newton. So how are we going to get this component, the x component? So we can say cos theta is equals to adjacent, which is x, over hypotenuse r. So we have cos of 50, our angle is 30, so cos of 30, which is equals to x, that's what we are looking for, and then our vector is 50 Newton. So x is equals to 50 the cos of 30 degrees. So when we punch that in our calculator, we get 50 cos of 30. It gives us 43,301. But then let's be careful guys, what is the direction of this component? Because it goes there, it should be negative, but then it's fine, we can leave it like this for now, but then we must note that it is negative. So let's say we are going to the next vector now for 80 Newton force or vector. What are the components? The y component is 0 because there is no component that goes up here. This acts horizontally on the x axis, so but then our x component is going to be 80 Newton. So let's see, we can say we have to add the components of the first vector and the components to the components of the second vector. So we can say y res, which is the resultant y of the first and second vectors. So the first one here, our y we said is 25, our second one is 0, so we have 25 Newton. Then x res, what do we have? We have negative 43,301, and then this one, how is it? It is positive, plus 80. So what do we get? We get negative 43,301 plus 80. We get positive 36,699. So basically 36,7, but then it's fine, we can leave it like this for now. So that's those our x rises, x, y resultant and x resultant. So how do they help us? So let's see guys, what do we have here? Our y resultant is positive, so it means it goes up, it is positive, and then our x resultant, it is positive as well, so it goes up. So it means our vector is going to be something like this. Or if we were to draw head to tail, we can say it is like this. This is our x is positive and our y is positive. This is head to tail method guys, head to tail method. Okay, so yeah, so if we were to draw our resultant, it's gonna be like this. So this is what we are looking for. So what do we see here guys? We have a right angle triangle. How are we going to get our resultant? Because here we have 25, here we have 36,7. let me make me 7 already Newton. So let's see, we have our y res as 25 Newton and x resultant as 36,7 Newton. Remember, it is this diagram guys. We have 25, we have 36,7 Newton. We are looking for this F res. so it is the resultant force, guys. So our average, what do we notice here? We notice a right angle triangle, like I said there. So we are going to use Pythagoras to get this. It's f rest squared is equals to x rest squared plus y rest squared. So we are looking for f rest. We can take the square root both sides, so it's x rest squared plus y rest squared. So let's substitute into this equation to get our f rest. It's going to be this: x is 36,7 squared plus this 25 squared. So let's punch this into our calculator and see what we get. 36,7 squared plus 25 squared. So we get our f rest to be equal to 44,41 Newton. So this is our f rest. So let's move to the next question. Is 2.2.3. It says the direction of the resultant net force. So what do they want, guys? We have our x rest, then our y rest, and then this is our resultant. We got it now as 44,4. This was 25, and then this is 36,7. So they want this angle, guys, the angle at which the resultant force is acting. So how can we get this angle? We are going to use this component here, this vectors actually. So it's going to be tan theta. We're going to use tan theta to get the direction. Tan theta opposite over adjacent, so it's going to be y over x. So it's going to be tan theta is equals to y, which is 25 over 36,7. So our theta, we are going to take the inverse of tan 25 over 36.7. So let's see, if we punch that on a calculator, what do we get? We are going to say shift tan 25 over 36,7 is equals to, so we get 34,26 degrees. So that's our direction for the resultant force. That's it, guys, for now. Thank you for watching.